Hello, my name is Nico Feld from the University of Trier and welcome to my talk about mixed reality in asymmetric collaborative environments, a research prototype for virtual city tours. Guided city tours are an essential part in tourism and the guide's performance is crucial for a successful and satisfying tour. Technologies like AR and VR can assist the tour guide and improve his or her performance. Further, these technologies can help to create a virtual city tour experience for various scenarios. Therefore, we think that using AR and VR in such a context can improve the overall experience. Further, a virtual guided city tour is a typical asymmetric collaborative virtual environment. In an asymmetric CVE, you have two user roles. The primary is the user with the main control over the virtual environment and contribute the most amount of information. The secondary mostly consumes these informations and is more passively. In a virtual guided city tour, the guide is in the role of the primary and the visitors are in the role of the secondaries. Further, a literature search showed that the primary in an asymmetric CVE usually does not use AR. Therefore, our main research question is if AR can support a primary in such an asymmetric CVE. In our work, we do not aim to answer this research question, rather we want to propose a prototype which allows further research. An asymmetric CVE which also used AR to assist the primary is the Dollhouse VR from Ibayashi et al. The work from Braun et al. Proposed a collaborative system for museums. The user either can visit a real museum with the PDA, visit a virtual representation via VR, or visit the museum via a website. We aim to be more immersive than the work from Ibayashi et al. And more intuitive than the work from Braun et al. In our prototype, a tour guide is using AR to perform a virtual city tour for multiple visitors. These visitors are immersed in the virtual city using virtual reality. To help the guide maintaining an overview over the virtual city, as well as interacting with each visitor on eye level, the environment of the guide is split in two different virtual working spaces. The desk zone is for maintaining an overview over all visitors and the virtual city. It is positioned around a real desk in the guide's real environment. On the desk zone, a small section of the virtual city with all visitors is displayed on an augmented wooden shovel. Further, an augmented map of the virtual city is attached next to the desk zone. On this map, the guide can see all visitors and the section of the virtual city that is displayed on the desk. With a sphere-based handle, the guide then can lead a visitor to a new location or change the section on the desk. When physically leaving the desk zone, the guide is automatically entering the warp zone. In the warp zone, the guide is immersed into the virtual city and can interact directly with the visitors. Further, the guide can interact with some objects in the virtual city via a radial menu. With this menu, a guide can either show a text or a video about this object or can highlight it. To create additional objects, the guide can use augmented documents or augmented wooden ships to create various new objects and show them to the visitors. Each user then can grab these objects and investigate them from all angles. Because of the current situation, we were not able to conduct a laboratory study to evaluate our prototype. Therefore, we first conducted an online survey about the prototype, and based on the results, we formulated 4 hypotheses. Then we invited few professional city tour guides to test our prototype hands-on in an expert interview. These results were then used to verify these hypotheses. The online survey was online for 49 days and had 31 participants. Based on the results of the online survey, we formulated 4 hypotheses. Hypothesis 1 is that the separation of working spaces and an intuitive transition can improve the workflow of the primary. Hypothesis 2 is that the usage of tangibles can support the primary in interacting with the system and the secondaries. Hypothesis 3 is that the combination of functionalities of real and virtual objects can improve the workflow, for example the augmented map. Hypothesis 4 is that the degree of realistic representation of the virtual city has an impact on the acceptance of the virtual city tour. To further verify these hypotheses, we invited 10 experienced city tour guides with the help of the Tourist Information Trier. As part of the expert interview, the guides reenacted a virtual city tour with our prototype. The participants stated overall that the separation is useful and easy to use. Therefore, we want to further investigate the separation and transition. Overall, we assume to accept this hypothesis, but further evaluation is required. For the second hypothesis, about the usage of tangibles, we faced many technical issues, especially with the tracking. However, the participants stated that the usage was intuitive. Therefore, we also assume to accept this hypothesis as well. About the combination of the functionalities of real and virtual objects, the results indicate a rejection of the third hypothesis. Therefore, we reformulated this hypothesis. Also, the results indicate a rejection of the fourth hypothesis about a realistic representation. Therefore, we reformulated this hypothesis as well. The overall feedback of both the online survey and the expert interview were promising and positive. Therefore, we see potential in our system design. In conclusion, we are confident that our prototype is a promising starting point to allow further research on the research question. Thank you for your attention.